Okay, so the very first thing is make sure your calculator is set to degree mode. So if you hit this little settings key here, scroll all the way down, make sure degrees is selected. And while I'm here, I'm just going to reset my grid to be -10 to +10 as well. All right, so once you have your settings ready, the very first thing that we're going to look at is what's called the inverse trig ratios. Okay? And so what that means is the following. Okay? If the sine of A is equal to, again, think about SOHCAHTOA. Okay? If the sine of A is equal to the ratio opposite BC over adjacent, or the hypotenuse, which is AB. So there is your sine ratio. Okay, what we're going to introduce here today is how do you, if you needed to actually find what the angle A is, how would you identify that? Okay, and so let's, again, kind of go back to our 3, 4, 5 common triple. So let's say we have our common triple here with legs of 3 and 4 and a hypotenuse of 5. If this were the case, then our sine of A is opposite 3 over hypotenuse 5. What we're looking at here is we can take and find what the angle is by doing what's called an inverse trig ratio. We can take the inverse of sine. The inverse is how this sine, what looks like to the power of -1, that's just spoken as the inverse sine of whatever that ratio is. And this is going to tell us what the angle represents. Okay? And so if we go into our calculators, under functions here, you see the inverse trig functions. So if we take the inverse sine and we put that ratio in, 3 over 5, what we see is this is the angle measure. So 36.87. That is the number of degrees for angle A. Okay, now, you could have used any of the trig ratios for this, right? I could have also set this up and said that the cosine of A is adjacent 4 over hypotenuse 5. And so if I wanted to solve for A, I could take the inverse cosine of that ratio 4/5. And if I did that, again here, if I take inverse to the power of, notice I can type in -1, I can write the inverse out, as well as to just find it in the function. But if I take the inverse cosine of 4/5, I get the same thing, right? I was expecting it should be the same thing. The angles are the same no matter which calculation you use to find it. Okay? And so I want you to see, I want you to use the tangent ratio and find angle B. If I set up the tangent of A, and then take the inverse tangent of whatever that ratio is and see if you can calculate what the angle B would equal. The tangent of B. So if I want to find what angle B is, I can set up the ratio for B is opposite 4 over adjacent 3. Right? That's TOA, opposite over adjacent. And so if I set my calculation for this, B is equal to the inverse tan of that ratio 4/3. And that's going to give me my answer. So again, if I take tangent to the power of -1, that gives me my inverse. And then in parentheses, write my ratio. So this is saying this is the angle that has a tangent ratio of 4/3, and it's 53.13. Does that make sense that that angle B would be 53.13? What should these two angles A and B add up to? You have a right triangle. Angle C is the 90-degree angle, so they should add up to 90, do they? Yeah, 53.13 plus 36.87, those add up to 90, so it's consistent with what you would expect. Okay, but that's what the inverse ratios represent. You may also see these written as arc sine. So inverse sine is the same as saying arc sine. The inverse cosine is the same as saying arc cosine, and inverse tan is the same as saying arc tan. So those are, you can interchange those as commands. Okay, but I want you just really quickly here, see if you can find these three angles using the inverse ratios on the calculator that you're using. So when we set up the problems above, we used the fraction form, right? We took the inverse sine of 3/5, but you could have also taken the decimal form. So that's what you're doing here on the bottom questions. To find theta, you're taking the inverse sine of that ratio or decimal. To find x, you're taking the inverse cosine of that decimal, that ratio. And to find theta, you're taking the inverse tan of that ratio. And so it's just a matter of entering those. So inverse sine, sine to the power of -1 gives you the inverse, 0.4695. So we get 28, approximately 28 degrees. Again, make sure you're in the right mode. Inverse cosine, cosine to the power of -1 gives you the inverse 0.7193, and we see 44 degrees. And then finally, I'll use the drop down here. We can also go into the function command and locate inverse tangent. Oops. We'll go to the next slide, go into the functions, access inverse tangent, type the ratio 4.0108, and we see 76 degrees would be our answer. So that's how you find unknown angles. You use the inverse trig ratios to find angles. You use the trig ratios to find missing side lengths. Okay, and so that's the new thing that we're adding here today, is how can you find an unknown angle. All right, so the types of questions that you're going to kind of be selected from are you're going to be given a specific right triangle, and you're either going to be given two pieces of information, either two sides, or a side and an angle. And from those, you can find all the remaining pieces of information for that triangle. So I'm going to show you on this example, and then we'll go through some examples with other sets of pieces of information. All right, so let's say here you're given two legs. If you're solving for a triangle that has two given legs, what do you think you can use to find the third leg, or the third side, the hypotenuse? If you're given two sides, 7 and 12, what would you use to find the hypotenuse here? Easiest thing would be use the hypotenuse, or use the Pythagorean theorem to find the hypotenuse, right? So if we wanted to calculate AB right here, we would simply say AB squared is equal to the sum of the squares of the other two sides. Extract your root, and notice there is our answer. So we can enter it as a calculation. Again, nice and simple. I can also enter my calculation here, 7 squared plus 12 squared, all inside that square root, and I get 13.89 approximately. So that's the first step. Use Pythagorean theorem, find your hypotenuse. And then once you find this, what you can do is use SOHCAHTOA to find one or both angles. Okay, so let's say we want to find angle A. Okay, if you now know, again, if you are given this information, and so if you're given two legs, use the exact numbers that you can. How do these other two pieces of given information relate to angle A? With respect to A, you have the opposite and the adjacent leg. Opposite and adjacent are related by TOA. And so to find angle A, you can say that the tangent of A is equal to opposite over adjacent, which means our angle A can be found by taking the inverse tan of that ratio 12/7. And so here, if we take tangent to the power of -1, that accesses the inverse tangent of the ratio 12/7, and that gives us our number 59.74. Okay, so there's angle A, and then if you wanted to, you can set up a trig ratio to find angle B. So one option for that would be, if we wanted to find B with respect to B, we have opposite and adjacent. So that, again, opposite and adjacent is TOA. So you could say tangent of B is equal to opposite 7 over adjacent 12, which means if we're finding B, we can take the inverse tangent of that. So we can just switch these around, right? The tangent to the power of -1 inverse tangent of 7/12. There's our answer, 30.25 or 27. Or sorry, 26. And that would be our second answer. So that would be one possible way. So that's why the or both is in parentheses there. But if you wanted to, you could also, instead of using trig ratios for both, once you find one of them, you can simply find the second angle by using complements. Okay, and remember, the complement means 90 minus the other angle is going to be your other acute angle. So we could have also solved for 30.26 by taking 90 minus this angle up here. Now, when you are accessing these, the easiest way to do this on the Desmos calculator is assign this a variable. If we just say A is equal to this calculation, what we can now do is take 90 minus A, right? And A calls back the value that you assigned to it. Now, don't give it X or Y. Give it one of those earlier numbers that sort of represents constants. And so if you let it be A, we now see that the complement to angle A is 30.26, and we could enter our answer from that. Right. So the different types of questions that you're going to see are just going to give you sort of different variations of this kind of information. So I want you to try on your own here this next slide. Okay. Can you solve for this triangle? You're given one leg and a hypotenuse. Can you find what the other pieces of information are? All right, so as I talk through this, you're going to see it's the same set of rules. You can use Pythagorean theorem here, but instead of to find the hypotenuse, this will be used to find the other leg. So here you're given two sides. And so if you say that, we'll call this A squared, or A squared plus 7 squared equals 13 squared. What you can do is subtract 7 squared from both sides and then extract your root. So notice we have our calculation right here, 13 squared minus 7 squared. And if you enter that directly, the square root of 13 squared minus 7 squared, you get 10.95 as your calculated value. And then, just like with the last version, you can now find your two remaining angles by setting up trig ratios, and you should use the exact values. Okay, so even though you can wind up, now you have both legs, so you could use tangent or inverse tangent to find these. The fact that you have exact values of 7 and 13 is set up the ratio for those. So if I have my angle A, I have an adjacent leg, and I have my hypotenuse. Which trig ratio relates adjacent and hypotenuse? So TOA, so cosine. So I know that the cosine of A is equal to my ratio 7/13, which means I can find A by taking the inverse cosine of that ratio. So here, if I take my calculation, inverse cosine of my ratio 7/13, there's my answer, 57.42. And so I can either set up the ratio for that, although the easiest thing for me to do is I'm going to assign this calculated value a variable. So I'm going to call it A. And that way I can just find the complement to A is going to be the other angle. So 32.58 is the easiest way to calculate and find that remaining angle. Okay? So that's how I would suggest you do it. Okay? All right. Let's see what happens if you're given an angle and a leg. Okay, so see if you can do this one on your own before I talk you through it. Okay, how would you approach this? All right, so this first time through here, again, you're given one angle. So the easiest piece of information to find out of the three here is going to be the other angle, right? What do we have to do to find this other angle? You can find the other angle by just finding the complement of the other angle, right? So if I just took 90 minus the given angle of 24, here I see that my remaining angle has to be 66 degrees. And remember, you can enter your answer as a calculation as well. So we could have entered 90 minus 24 directly into our answer field. And once you have your angle, what you can now do is you can use trig ratios to find both missing sides. So if I want to find BC, which I'm going to call lowercase a here just because it's opposite angle A, and I'm going to call the hypotenuse C because it's opposite angle C. So if I want to find this angle A, I can choose to use the side A. I can choose to use either angle A or angle B. It doesn't matter. They're both exact numbers. I'm just going to use A here as a reference. So with respect to A, I know that angle. I want to find the opposite leg, and I know the adjacent leg. So which trig ratio relates opposite and adjacent? TOA, so tangent. So the tangent of A is equal to my opposite A over my adjacent 7. And so when I'm calculating this, multiply both sides by 7, I get my answer here of 7 times the tangent. Oops. My A value, I actually have it. It's not A here. It's 24. So the tangent of 24 degrees. And then I multiply that by the 7, and I get my value here for A to be 3.12. So A, which is BC, is 3.12. And to calculate my remaining value, you have some choices. Okay? The first choice is you can do the exact same thing, find a trig ratio that relates these. So if I want to find C, I can use either angle A or B. Since I already used A, I'm just going to use it again. So with respect to A, I have 7, which is adjacent, and I have hypotenuse. So adjacent and hypotenuse is related by which trig ratio? So TOA. So I could set up the cosine of A is equal to adjacent 7 over hypotenuse C. Multiply both sides by C to get it out of my denominator, and then divide. Oops, I wrote A again, but I actually know what A is here. Let me replace that. A is 24 degrees. So I'm going to divide by cosine of 24. And so I get my answer to be here, 7 divided by cosine of 24. And that gives me my other answer, which is 7.66. And so those would be my solutions using that. Now, the other possibility that I could have done is I could have used Pythagorean theorem to find C. The problem with that, if you are going to use Pythagorean theorem for this, what you would need to do is, you know that this is 3.12, but it's an actual, you have to use the actual values for it. So if you were going to use Pythagorean theorem to find C, you would say 7 squared plus 3.12 squared is equal to c squared, and extract your root. If I was calculating that, what I would get is the square root of 7 squared plus, and instead of writing 3.12 here, I'm going to let that be a. So I need to go back up for this number right here, and I need to say a is equal to this calculated value. Once I do that, I can then use that a in my calculation, and notice I get the same thing, right? 7.66. So if you are going to use Pythagorean theorem for that, you just need to assign the value an exact number. Because if you use 3.14, or if you use 3.12 here, if you had put 3.12 squared here instead, oops. Notice in this case it wound up being enough, but it might be off by a tolerance level that doesn't allow you to have the full points. So just be careful on that. If you are going to use a calculation, assign a variable to the exact number, the exact calculation, and then refer to that variable in your calculated number. All right, let's try this next one. See if you can answer the questions on this next problem. Again, same process. All right, so once again, easy piece of information to find is the other angle. So I'll repeat that. So the easiest piece of information to find here first is the other angle, because they are complements to each other. So the complement of 70 is 20. So 90 minus 70, or 20, would be your answer. So that's the first piece. It's an exact answer, so you're good there. And then to find the remaining pieces, you're going to use trig ratios. So again, if I call AC lowercase b, and if I call AB lowercase c, because they're opposite the angles with those letters. And what I can do is I can find either one first. It doesn't matter which one I find first. Okay? Again, normally what I would want to do, it's easiest if you use a calculation where your variable is in the numerator. So to me, if I'm going to use angle A again, which I'm going to, just to be consistent with that, then my first value B is adjacent, and my opposite. So I have opposite and adjacent. Notice my adjacent one, though, is not going to be in the numerator. Okay, so ideally you have the adjacent one, or I mean the unknown in your numerator. So it's probably easiest to actually solve this by using angle B instead. But let's say we did this anyway. So we saw from angle A we have the opposite and adjacent. That's related by TOA. And so if we take the tangent of A, which is 70 degrees, is equal to opposite 6 over adjacent B. We can multiply both sides by B and then divide by the tangent of 70. And that would give us our answer. So if I took 6 divided by tangent of 70, there's my answer, 2.18. Again, this is an approximation that I entered in because you can see from the decimals here, it's more than just that. Okay, and so when I calculate my remaining value C, so I now know that this is approximately 2.18, but again, it's an approximation. So if I take A, I have a known opposite and an unknown hypotenuse. Opposite and hypotenuse are related by so. And so I can use the sine ratio of 70 degrees is equal to opposite, which is 6, over hypotenuse, which is C. Do the same thing. Multiply both sides by C, isolate that C by dividing both sides by the sine of 70. And so my answer winds up being 6 divided by the sine of 70. And when I do that, I get my final answer, which is 6.39 approximately. However, I could have used Pythagorean theorem on this, If I was using Pythagorean theorem to find AB, I would say that c squared is equal to 6 squared plus b squared, where b is this 2.18. Extract my root. And so I could actually say square root of 6 squared plus b squared. I simply need to make sure that this is equal to b. So if I go up to my calculation and I say b is equal to, I can come back and it gives me the same exact value. So you could use Pythagorean theorem if you wanted to. If that's the case, you're just going to assign a variable to your first length, okay, and then you can use the Pythagorean theorem to find the remaining one. Again, you have some options there. All right, let's try one last sort of variation of right triangle where you're given part of the information. You're given an angle and hypotenuse. Okay, see if you can find the remaining values there for that, please. All right, so the settings here are the steps here are pretty much like what we just saw. If you're given one angle, the easiest thing to do is to find the other angle by taking its complement. So 90 minus 61 would be your first step, giving you 29 degrees. Okay, and then to find the remaining sides, again, I'm going to label them A and B, just based on the angle letter opposite the side. And so you're going to use trig ratios to calculate these. If we take the first, again, you can choose either angle to start with. I'm going to take my angle of 61 degrees, and I'm going to find the A value first. So A is opposite. I have my hypotenuse. Opposite and hypotenuse are related by so. So I know that the sine of 61 degrees is equal to the opposite A over 22. And so if I just multiply both sides by 22, there is my A value. Now, if I'm already anticipating to use the Pythagorean theorem, I can go ahead and just say A is equal to, and then take my trig ratio, 22 times the sine of 61. So 19.24 is A. A is BC, so make sure you're entering that in the correct spot here. So 19.24. And if I wanted to use Pythagorean theorem, I could say that b squared plus a squared is equal to 22 squared. Subtract a squared from both sides because I know what that is, and then extract my root. And so I could, for AC, type the square root of 22 squared minus a squared. I've already assigned a squared a value, so I get 10.67 approximately for my AC value. However, if I was solving this by using a trig ratio, what I would do, choose either one of my angles. I'll choose angle A here. I have adjacent, and I know my hypotenuse. So adjacent and hypotenuse is cosine. So the cosine of 61 degrees, my A value, is equal to adjacent, my unknown B, over the hypotenuse, 22. So if I did this calculation as well, 22 times the cosine of 61, it should be the same value that I just found for AC, which is 10.67 approximately. Okay? So again, it doesn't matter whether or which of those methods you choose. It's completely up to you. All right. So the last types of questions that you're going to see. Well, not the last. So the last part of solving the right triangles is to do story problems involving these. And if this is the case, you have to choose. Are you going to use Pythagorean theorem or trig ratios? Okay, anytime you see a right triangle, that's what you should try first. And so I want you to see if you can answer all three of these. All right, so I'm going to start talking through these. I'll start at the top and kind of work my way down. So the whole point on these types of questions is your unknown an angle? If it is, you're probably going to use inverse trig ratios. Is your unknown a side? your unknown is a side, you're either going to use Pythagorean theorem if there were no angles involved, or you're going to use trig ratios if there's an angle involved. So when you look at all of these here, it looks like all of these are asking you to find unknown angles. So more than likely, you're going to use the inverse trig ratios. So with respect to this angle, which is designated as theta, you have an opposite leg and a hypotenuse. Oops, opposite and hypotenuse are related by which trig ratio? So sine. So the sine of theta is equal to opposite over hypotenuse, which means our angle theta is going to be the inverse sine of that ratio. And so there we go. As long as you are in degree mode, when you enter this, which angle has a sine ratio of 11 over 19, and you see that it's 35.38, and that would be your answer. Okay, so once you identify the correct trig ratio, you can set up your inverse and find the calculated value. Okay, let's look at the problem down on the bottom left. So here's your tower. You have this unknown angle, and on this one you know your adjacent leg and you know your hypotenuse. Adjacent and hypotenuse are related. Oops. Adjacent and hypotenuse are related by which trig ratio? So cosine of theta is equal to adjacent 25 over hypotenuse 40, which means your angle can be found by taking the inverse cosine of that ratio. And so once again, it's just a matter of entering that calculation. So inverse cosine of the ratio 25 over 40, and there's my answer, 51.32. And so that would be my angle measure. The final question here, when you're looking, you have this angle of this boat. Now notice it's asking you here, what's the angle of depression? We talked about this. The angle of depression and this angle of elevation all just are based on perspective, right? So they're equivalent. So if I can find what theta is, then that angle of depression is the exact same measure. So I'm going to go ahead and use this known angle here. I have an opposite leg, and I have an adjacent leg. So opposite and adjacent are related by which trig ratio? SOHCAHTOA. So the tangent of theta is equal to opposite 90 over adjacent 104. Therefore, my angle theta can be found by taking the inverse of that ratio. And again, there's my answer. I type that in. Inverse tan of the ratio 90 over 104. And I get my angle to be 40.87. A nice quick calculation. All right. This is the end of what's in your notes. So what you'll need to do here, I have one more slide to kind of go through because I am talking through sort of the summary of right triangles is part of this homework as well. Okay, and so I have these two questions to add. Oops. Let me see if I can resize them. All right. So go ahead and if you want, you can take a screenshot of this and you can add an empty or add a page to your Notability. So if you click this button right here, the Pages button, and then click on the three dots, enter Add a Page, and then you can take a picture of this slide. I am going to talk through these two questions here as well. All right, so we're just looking at this top one right now, and I'll talk through it and give you a chance to answer the bottom one in a second. All right, so here you're being told you have this right triangle RST, and it's similar to triangle UVW, and it gives you the pieces that are similar, right? S and V are similar or correspond, and T and W correspond. Okay? Now, in order for you to figure out which one of these is the right angle, how would you know which of the points is going to be your right angle? Any ideas? When you look at these three side lengths here, which of those side lengths do you know has to be this length right here? In a right triangle, that's the hypotenuse, and what do you know about the hypotenuse? It's the longest side, right? So what you know is that this has to be the 325. Now, once you determine that, it doesn't matter where you put T and R, right? All you know is that that leaves S to be the right angle. So if you label it this way, you can now type in 280 for SR, and you can type in 165 for ST. But that also allows you to see where S corresponds to V, so that means V is the right angle. T corresponds to W, so W is here, and that leaves U to correspond to R. So now you know what your other triangle is going to look like. Okay? And so if you want to find what's the tangent of W, well, the tangent of W is TOA, opposite over adjacent, and that means because in similar triangles, corresponding angles are equal, the tangent of W is going to correspond to the tangent of which angle in the other triangle? T. So the tangent is opposite over adjacent, so our answer is going to be 280 over 165. And so if we just calculate what that is, oops. So 280 over 165. We want the fraction form, the rational form. We get 56 over 33. And that would be our solution for that problem. In the second example, triangle FGH and triangle JKL are similar. Here they actually tell you what the right angles are. G and K are the right angles. And so if you label F and H, and F corresponds to J, so J will be in the corresponding position as F, which leaves L in the corresponding position for H. And what you can do is you can use the trig ratio, SOHCAHTOA. Sine of F is opposite over hypotenuse, so that means that the opposite is 200 to the hypotenuse 250. And so if you're finding what is the sine of J is also opposite over hypotenuse, so it'll also be 200 over 250. Now, if it had asked you for the sine of L, you would need to use Pythagorean theorem to find what this missing leg would be.